students. Chemistry, we say that, is the science of molecules and atoms because chemistry deals with the matter, its composition, structure and properties, and matter is made up of atoms and molecules. Today we will study about some basic concepts of chemistry, that is Unit 1 of class 11th. Matter. Anything which has mass and occupies space is known as matter. Matter exists in three physical states: solid, liquid and gas. It all depends upon that how the constituent particles are packed and the strength of the intermolecular forces. In the solids, the constituent particles are very closely packed and the intermolecular forces are very strong. In liquids, as compared to the solids, the molecules are not so closely packed, and in the gases, the molecules are very loosely packed. Let's see. The solids, they have a fixed and the rigid particle structure. It is only because the constituent particles are very closely packed. Liquids have weak bonds and the molecules are free to move. Gases have no bonds among different atoms and molecules. Liquids and gases can take the shape of any container. In liquid state, the molecules are not closely packed as compared to the solid and they can move freely. But the liquids have the fixed volume and they can take the shape of any container. Gases, the intermolecular forces are very weak and the molecules or the constituent particles are free to move. The gases neither have fixed shape nor do they have the fixed volume. All the three states are interconvertible. We can change solid into liquid state, liquid into gaseous state and vice versa. Matter. Matter is classified into mixture and pure substances. Mixture are further classified into homogeneous mixture and heterogeneous mixture. In the homogeneous mixture or the heterogeneous mixture, the components are mixed in any ratio. But in the homogeneous mixture, the uniform composition is there. You cannot see the separate components. But in the case of the heterogeneous mixture, you can see the separate components. That is, the composition is not uniform throughout. Now, the pure substances. The pure substances are further classified into element and compound. In the element can be monoatomic or polyatomic, but the elements are made up of same type of atoms. Compound. Compound is again a pure substance, but it is made up of two or more elements combined in a fixed ratio. Now let's see the International System of Units, which is also known as SI System of Units. There are 7 basic physical quantities which are also known as the fundamental quantities. These are length, mass, time, electric current, amount of substance, thermodynamic temperature and luminous intensity. The symbol for the quantities: for length we use small l, for mass small m, time small t, electric current capital I, amount of substance it's small n, thermodynamic temperature it's capital T, and for the luminous intensity it's IV. The units: the unit of the length is meter, for mass it is kilogram, time it's seconds, for electric current the unit is ampere, for amount of substance unit is mole, temperature it is measured in kelvins, and the luminous intensity it is candela. Mass and weight. These two things are altogether different. Mass is the amount of the matter contained in a body or contained in a substance. Weight. Weight is the force exerted by the gravity on an object. Mass for a substance is constant and we can measure it using an analytical balance. Gravity varies from place to place. For measuring gravity, we use spring balance. Temperature. Temperature is the degree of hotness or the coldness of a body. We use three fundamental scales to measure temperature: degree Celsius, degree Fahrenheit, and Kelvin. All these three scales are interconvertible. We can convert degree Celsius into Kelvin by adding 273.15. For example, 0 degrees Celsius is equals to 273.15 Kelvin. Similarly, 100 degrees Celsius is equals to 373.15 Kelvin. Degree Fahrenheit can also be converted into degree Celsius by using the formula degree Fahrenheit equals to 9/5 into temperature in degrees Celsius plus has 5 significant figure. Here in this example, 0 is lying between two non-zero digits, that is 1 and 1. So here 0 is significant. Here 5 significant figures are there. All those zeros which are before the first non-zero digit are non-significant, or we can say that insignificant. For example, 0.00052 has only two significant figures because all the zeros are before 5, which is the first non-zero digit. So here only two significant figures are there, that is 5 and 2. Next rule. Trailing zeros in a number containing a decimal point are significant. That is, all those zeros which are after decimal are significant. Let's see an example. 12.2300 has 6 significant figures. Here the two zeros are after decimal, so they are also significant. Now let me take another example. 0.000122300 still has only 6 significant figures because all the zeros before 1 are insignificant. So we have to follow all these rules while writing the significant figures. Addition and subtraction of significant figures. Count the number of the significant figures in the decimal portion of each number in the problem. That is, in the problem you have to see that how many decimal places are there. The digits to the left of the decimal place are not used to determine the number of the decimal. While writing, first of all, add or subtract just like we do in the normal addition and subtraction and find out the answer. Then while reporting the answer, you have to follow a rule. What's that? Round the answer to the least number of the places in the decimal portion of any number in the problem. That means we have to see that which number has the minimum number of the decimal places. Our answer must have that minimum number of the decimal places. Let's see an example. 12.11 plus 18.0 plus 1.012. I am adding it in a very normal way, a normal addition. 31.122 is the answer. But I will report the answer to the significant figures, that is 31.1. Now why my answer is 31.1? Because one of the number in the problem is 18.0. It has only one significant figure after decimal. So my answer should have only one significant figure after decimal, that is 31.1. Rules for multiplication and division of the significant digits. The least number of the significant figures in any number of the problem determines the number of the significant figures in the answer. That is, the numbers we are multiplying or dividing, then our answer should have only that number of the significant figure in which our number have the minimum number of the significant figures. Let's see an example. I'm just multiplying 2.5 into 3.42. The normal multiplication, the answer comes out to be 8.55. But the answer reported is 8.6, that is, it has only two significant figures. Why only two significant figures? Because the two numbers which I am multiplying, 2.5 and 3.42, out of this 2.5 has only two significant figures. So my answer should have only two significant figures. This is all about the rules which we follow doing simple calculations. So dear students, now we have studied that the rules for writing the significant figure is very much clear to you. So today we have studied that what is matter, what are the three states of matter, and what are the fundamental basic quantities.